Okay, so let's look at how to find the domain and range if you're given an equation or a formula. So this would be called finding this algebraically. And I've broken this down into 4 types of functions, and you can combine these together, but these are kind of the 4 base types of functions we'll work with. So polynomials, so those are things like x squared minus 7x, something of that nature. The domain for those, so all of the x values you're allowed to put in would be all real numbers. You can put any negative, positive, 0, anything like that in there is fine. So you can write that as the R for all real numbers. You could do negative infinity to positive infinity. You could do negative infinity less than x, less than infinity. Any of those will work. All right, and then we have roots. So there are 2 types of roots, either an odd root or an even root, and they have different domains. So an odd root would be like a cube root or the 5th root. And for an odd root, your domain is all real numbers. So you can take like the cube root of -1. That is allowed. I had -1. I took that cube root. And that's because -1 times -1 times -1 is equal to -1. Right? So this is -1 cubed is -1. So if I took the cube root, I would get a -1 back. So you can put negative numbers in there, you can put 0 in there, you can put positive numbers in there. Any of those are fine if you have an odd root. Now, if you have an even root, then whatever is underneath of the root sign, that whole piece in there has to be greater than or equal to 0. Right, so if we think of an even root, like a square root would be an even root, you can take the square root of 0, you can take the square root of a positive number, but you can't take the square root of a negative number in the reals. So if you're using imaginary numbers, you could do that, but we're not going to use imaginary numbers in this class. So you need whatever is here to be greater than or equal to 0, and you want to solve that. Okay, so if I was looking at this one, the 4 tells me it's an even root. We have x minus 7 greater than or equal to 0, so x is greater than or equal to, 7 here. Okay, so I'd add that 7 to the other side. Right, and then rational functions. The only issue you really run into with rational functions is you can't divide by 0. So you need to take whatever is in the denominator, that g of x, set it equal to 0, or say it cannot equal 0, and then solve for that. Okay. So for example, x plus 15 cannot equal 0, so x cannot be -15. I can plug any other real number I want in other than -15, and I will get a value out of that. All right, to find the range algebraically, you can rearrange these equations to solve for x, if that's possible to do. It's not always very easy to do, or you get something really complicated out of that. So kind of depending on the complexity, it might be easier to just graph it to find the range. Okay? But I do expect you to do on the homework and on the test to be able to find the domain algebraically. Okay? I won't ask you to find the range algebraically, I don't think. If I do, I'll give you a heads up on that. But all right, so let's give this a try, and then I'm going to have you pause the video and try some on your own. So we're going to find the domain only for each of these, and the best way to do that is kind of to start by identifying what type of function you have. So here I have an x cubed plus a 4x squared minus a 7x plus 8. That is a polynomial, and I know polynomials are all real numbers. Number 14, I have the 5th root of x plus 3. So I have a root, and I have an odd root. So the rule for odd roots, put any number I want in there for the reals. So that's all you got to do. All right, 1 over x plus 6. So this is a rational function. Rational functions often look like fractions. Okay, try to say that 10 times fast. Function, fraction. Okay, so the deal with these is that we cannot divide by 0. So I'm going to take the denominator, so x plus 6, and say it cannot equal 0, and then I'm going to solve. So I'll subtract 6 from both sides. So I get that x cannot equal -6, but I can put any other real number I want in there. And then 16, so I have the square root of x squared plus 9. So if there's no number here, that's always assumed to be 2, it would be a square root if there's no numbers. That makes this an even root. And the deal with even roots is whatever's inside the root has to be greater than or equal to 0. So I get x squared plus 9 greater than or equal to 0. I'll subtract 9 for both sides. So I get x squared is greater than or equal to -9. And then I need to look at this a little bit more closely. Is x squared always bigger than -9? The answer to that is yeah, because x squared is going to be 0 or positive. So this is actually an always true statement. Okay, so no matter what value I put in, I'm always going to have 0 or something positive in here. So that means that I can put anything I want in, or all real numbers is my domain. All right, so I would like you to pause the video, try the remaining 8 on your own, and then we'll come back and take a look at those. Okay, so hopefully you gave those a try. Let's take a look at what we've got here. So, I have another even root. Okay, so the deal with even roots is I need the inside part of the root to be greater than or equal to 0. So I have x plus 5 greater than or equal to 0. Subtract 5 for both sides, and I get x has to be greater than or equal to -5. Okay. So for example, if I plugged in a -3, I would get -3 plus 5, so I'd have the 4th root of 2. Now if I broke this, if I plugged in a -10, then I'd have -10 plus 5, which is a -5. I can't take the root of a negative number there. All right, number 18, 1 over x squared. So this is a rational function. And that means I need x squared to be not equal to 0, which means just x is not equal to 0. Number 19, that's a polynomial. So we know polynomials are all real numbers. I have another rational function. So for a rational function, I just need the denominator to not be 0. So if x squared plus 5 is not 0, x squared, then if I subtract 5 from both sides, I get x squared cannot be -5. And that's always true in the reals, right? I'd have to use imaginary numbers if I wanted to try and take the square root of that, and we're not dealing with imaginary numbers. So this is also always true. So I get all real numbers for this one. All right, 21. This is a root, and it's an odd root. So odd roots are all real numbers. That's all you got to do. 22. This is a polynomial. You could FOIL this out, and you'd have some sort of x cubed and an x squared term. So polynomials, their domain is all real numbers. 23. So I have another rational function. I have x squared minus 9 cannot be equal to 0. And then you have two ways, there's kind of two ways I can think of off the top of my head to solve that. One would be to factor it. So x minus 3, x plus 3 cannot equal 0. And generally that's what you want to do is factor it, because they're usually not quite as nice and pretty as this one is. Which means x cannot be plus or minus 3. On this particular one, another way you could solve this one would be x squared cannot be equal to 9. If you take the square root of both sides, you get that x cannot be plus or minus 3. Okay. The reason I would steer you away from this is if you had something like 1 over x squared plus 3x, I don't know, plus 5, then you would need to factor this. Okay, and you can't just move like the 5 over to the other side and try and solve it. So generally it's going to be a factoring situation. 24, last one on this, and this is an even root. And this means I need x squared minus 16 to be greater than or equal to 0. So that means I need x squared greater than or equal to 16. Right. When you solve these kinds of inequalities, this is going to take, there's some work behind this, but I think we could probably logic our way through it rather than kind of maybe diving into all of those details for this at this point. So the way to think about this is I'm definitely going to end up with some sort of issue with or x is a plus or minus 4 here, right? There's something related to that going on there. So if I look at this and I just think about things, so if I put 5 in here, that would give me 25 minus 16, right? 5 squared is 25. And that'll work. That gives me a positive number. So I look at that and I say, okay, well, that means I definitely want x to be greater than or equal to 4. How does the negative 4 fit in there? Okay. So what if I looked at negative 2? So plug x equals negative 2 in here. Negative 2 squared is 4. And 4 minus 16 is a negative number. So yikes, I probably want to stay away from that negative 4 to positive 4. And if you plug in something like negative 8, you'll see that this ends up being positive. So the other piece of this is that x is less than or equal to negative 4. So you just want to keep an eye on that when you're doing those ones with those even roots and the greater than or equal to 0 on that. Okay. Okay, and I want to look at one more hybrid here. So I've put this up, 1 over the square root of x plus 2. So this has both an even root to it and a rational function, right? So the rational function tells me that the square root of x plus 2 cannot be 0, or I'm going to run into problems. And the even root part of this tells me that x plus 2 has to be greater than or equal to 0. Right, so I need to combine these two together. The way to do that is to say x plus 2 has to be greater than 0, okay, which means x has to be greater than negative 2. And that would be your domain. Okay, and the reason it's strictly greater than is if we plugged a negative 2 in here, so negative 2 plus 2 is 0. The square root of 0 is 0, but 1 divided by 0 is a problem. Okay. All right, so hopefully that gives you a little bit of insight into some of those hybrids there, and we'll come back and look at the restricted domain problems.